So I have a hot take that's interesting to me, and I'll tell you why in a bit. But the hot take is, can Tesla achieve full self-driving with their current technology stack?
Welcome to the Deep Chat.
All right, well, that's asked in a very binary way. If I have to hot take it, it's a pretty easy yes. Number one, because you didn't put a time frame on that. But number two, it implies a doubt.
Well, okay, let's time frame it. Let's time frame it in the next 5 years.
Oh, I mean, because now the question is, there's the technology side of it, and there's like the compliance and legal side of it.
Technology purely, not the compliance and legal. Forget about compliance.
Well, yeah, the technology is more or less there now. All the statistics
Really?
all the data they have hundreds of thousands of hours of these cars on the road, and their accident rate is orders of magnitude smaller than the drivers on the road. Now, it's a little bit apples to oranges because, people are driving everywhere. Those cars are driving kind of closed course-ish sort of stuff. But that biased statistic says they're much safer than people.
Well, yeah, but that's not full self-driving yet. You couldn't take it anywhere and drive on any conditions. I mean, they're testing that. They're effectively in beta, driving on city streets.
Yep.
Then there's the dealing with snow and rain and et cetera. And I do have some experience here in terms of actually driving.
Oh, I have no hands-on experience, so I would love to hear your side of that.
And this is where my curiosity comes in. So we had the Model X, which is the highest-end Tesla with the gull-wing doors. And I've had access for, 3 years now to the self-driving portion of that. Back then, it came default. Anything, the Tesla would drive itself for the most part. It wouldn't stop at red lights. It wouldn't stop at stop signs. You could only use it on the freeway. I could be wrong in saying that maybe we didn't purchase something more, but I will say this, it will drive down. Just 2 years ago, it would drive down Topanga Canyon by itself. Okay, so Topanga Canyon, for those that don't know, is a very windy canyon road that goes up into the mountains from the coastline. And it's pretty impressive at how well it navigates that. Then we switched to the Model Y just recently, so I get to see the difference between the two models. Ours was slightly older, and this new model, which doesn't have, I believe the old model had sensors that allow it to see around things, not acoustic, but radar sensors. I'd have to double check. But this model, Model Y, only has cameras. It will show you, you can preview what it would look like if I had bought the full self-driving. It's $12,000, which seems absurd to me, for full self-driving. And for a product that isn't even, you're not supposed to take your hands off the wheel. So you're going to pay $12,000 for something that technically is a beta version. You're not supposed to let go of the steering wheel. And it'll warn you. It'll be like, we don't sense your hands on the wheel. You got to put your hands back on the wheel. So I'm not going to buy that. And it doesn't make sense to me to buy it, in my mind, because it's not actually full self-driving. You have to have your hands on the wheel, and it will say, please, grab the wheel, because it can sense the feedback that you're giving it. But I can look on the display, and it will show me every red light. It'll show me people walking. It'll show me cars, buses, motorcycles, stop signs, and it sees them. Now, the important thing to note here is that it's my understanding this is all a visual system. This is not additional sensors like Lidar, which I know that other companies are using, Lidar, and they say that full self-driving will only be possible with Lidar. When I take a look at that, and if I'm forced to hot take it knowing what I just said, that's about all I know. Because humans use only our visual system, there's zero reason why we couldn't develop a car that only uses the visual system to navigate. I don't see any reason why not. But as you said, it's the timeline.
Well,
right, when?
But no, you jumped to the back of the book and looked up the answer. You hit it on the head. That's exactly right. It's just from an information theory standpoint, if a human can do it without those sensors, you have to be quite a bigot to believe that a machine can't also do it.
What are the impediments here? When I look at it, if they can identify every single component with a high degree of accuracy, I just don't see any near-term obstacles other than regulatory. Because by the end of, there is going to be a lot of people who pay for the $12,000
Sure.
full self-driving, and they're going to use it, and they're going to use it a lot. Okay, so now they're getting data, right?
Yep.
From all of the sensors and those people who bought that. My guess is they also get data from when you drive your car, that they're starting to map all the roads and the patterns of the roads, like that Topanga Canyon Boulevard, right? That very windy road. If you've had 1 million passes go down there, 1 million cars take a pass at that road, I mean, that's an inordinate amount of reinforcement learning, right? I suspect they're probably using that as well. It just seems like they should be there in the next 3 years. I don't know.
All right.
Given all that, what are your thoughts? You're more of an AI expert far more of an AI expert than me.
Well, I just had a very dystopian aside. You're right. They're gathering a lot of training data, but think of it this way. Imagine the driving style of a person that'll pay $12,000 for this package. This sounds like an arrogant driver who's going to cut me off. That's what we're training the machine to learn to do. Think of who's training it. The guy that will pay $12,000 for it. It's that driver who.
Yeah. Well, I mean, maybe you're right, because there was a study. Like, I will say this: there was a study that they tested, measured cars and the expensive versus less expensive cars at stop signs, and who heeded right away and who was quick to take it when right away wasn't theirs, etc. I remember this study, and the high-end cars were not as nice. Let's put it that way. They were overwhelmingly not as nice. I forgot the term for it, but basically, the well-off, presumably by their car, right?
Sure.
Were just more impolite. So the question is, if we're training off those impolite people, are we training the vehicle to be, impolite or rude or take risks?
Well,
and my answer to that, and the answer, would be that there are, core sets of rules that it can't go beyond. Like, for instance, obey right of way, which I'm sure that they're building in. It's like strict right of way, and then don't hit another vehicle. So it's all gonna be superseded. Any kind of impoliteness that is trained into it would be superseded by the core sets of rules that they probably put into it.
Yeah, machine learning is certainly not so naive, nor is it this black box that the media would have you believe it is, that we just throw things in and nobody has any idea how it works. That's a complete fiction. Even if your training data is polluted with bad drivers, there will be mechanisms you use to correct that and still learn from it in some negative way and all these sorts of things.
Do you suspect that they're leveraging the miles driven of all their cars on the roads and kind of getting a overall map of all the roads in America? I mean, wouldn't that be what you would do?
Yeah, I mean, almost certainly. The caveat is that you probably have, so there could be some weird privacy thing, right, where you're not allowed to, so you got to respect that. But hopefully it's opt-in and everybody opts in, because why wouldn't you want to help in this effort, as long as it's anonymized and all, that kind of stuff. So they still would need to segregate data between training they built on closed courses, which has one important use case in machine learning, and this anything goes dirty data set that has everybody in it, which is also important, but you're going to use those two things in different ways.
Right. So I'll give you an example. Like, when I let it drive Topanga Canyon Boulevard, it tends to, in certain instances, go a little wider than I would like come closer to the center lane on sharp turns than I would like. And I'll auto correct it when there's cars, because it's just a little uncomfortable. And I'm not sure if that's due to the fact that that's how it reads the lines, or that's how a lot of normal people drive, because on this road, there's a lot of panic drivers, right? They drive really slow because there's canyon walls all around, there's rocks, there's a steep drop off. And I'm wondering if it was trained that people stay away from the rock face And so they err on the side of the yellow lines, because nowhere else, when I'm driving on a standard road and I let it, auto steer, nowhere else does it kind of err on the side of the double yellow.
That's very interesting.
It doesn't, so it's weird. I just feel like maybe it's been mistrained in a way there, and that's the only incidence of it I can point to.
Well, so let's unpack that. I have no ability to look inside these companies. I don't, even though I've interviewed people who work there and stuff like that, I don't have any deep access where I know exactly what they're doing, but I can speak to what's possible. And it's very reasonable that they could have architected their system such that they have all this metadata about the road, such as, is there a rock face that could drop rocks? And they know from some civil engineering study that statistically the safest thing to do in that length of road is to hug the yellow line. And then recognize from the metadata, okay, we're in this scenario, we have this rule, tell the machine to optimize a certain parameter. Normally it keeps you whatever distance from that line. Now it wants to optimize it to some much closer rating. That's all very doable. It wouldn't be a surprise if that was running on the road today. However, that would not emerge naturally out of the types of ML we do today. That would have had to have been the combination of like a product engineer who said, let's build this scenario Kyle just talked about, let's get all the road metadata collected, and then let's make sure the ML system can take these parameters so we can tell it this constraint we want under this scenario.
Interesting. So yeah, that may be the case.
If not, let's patent that, because, hey.
Yeah. I would think, having great data, I'm sure they have great data scientists on their team. They tend to hire really good people, obviously. My guess is that they're, if we can think of it, they've thought of it. They've got a whole team dedicated to this. And that's often my assumption with, like, when coding something is if it's a universal need, or a need, if I think I need it, then likely there's other people who need it, and there might be a library that already does it. And most of the time that's true.
Yeah,
so
fair bet.
In this case, having that information seems valuable, and I would suspect that they're incorporating it. Metadata is important.
So here's the reason why not. The reason why not is... well, let me take a brief aside and give you one of my favorite quotes, which may or may not be true. I think it was Werner von Braun, who was like the lead scientist on the Apollo project to land a person on the moon. And at some point, he's being interviewed, and the interviewer says, how many people on your staff for this project? And he says, well, we had, these engineers, these math people, this, adds it all up. He says, I guess there was about 100 people on the project. And the interviewer says, took you only 100 people to put human beings on the moon? That's incredible. What do you think you could have done with 200 people? And he quickly responds, with 200 people, there's no way we could have got this done.
Did he really? Someone said that. Is this a story?
I've never looked it up because I would be sad to find out it's not true. I'm living in like a Santa Claus kind of thing right now.
Such a great quote, though, but it's true.
Yeah.
Like, I'm surprised they got it done with 100. It's so hard to coordinate that many people.
So it could very well be that it's just, when I said so casually, they have metadata on the road and they know falling rocks and there was a statistical civil engineering study, all that stuff, that's like 300 years of human work hours I just described into 2 sentences, perhaps, to collect all that.
Yeah, that's true. Like, where you'd have to collect it, but where is the metadata? Maybe there's a data set that exists. Maybe Google sells that.
Could be.
From its image identification, or that's an interesting data set. I can't think of USGS.
Yeah, something.
Geological data sets.
It's a 6-figure salary to even find the right person to answer the question.
Yeah, that's right. It is. So, you could go so far as to say, what are the roads built from? Is there a guardrail? Because if there's a guardrail, if there's not a guardrail, you might make different decisions about what you do, right?
Oh, yeah.
If there's a guardrail, I know that people, when driving that road, would err on the side of the yellow line in the center to stay away. They would stay away from that edge. I already see enough people going up and down that road that go slow when they're nervous, and you can see it. So all of those pieces of metadata could be interesting, but nothing trumps, I would imagine, having the data about how people navigate that road safely, right?
You have not, for everyone who goes down, there's a variance in the weather conditions and their performance. And the more of that you're tracking, the more of a solid data set you have to work with.
Yeah, and I imagine they throw mine out. And this is a machine learning question is most people are going to stick the center of their lane, right? Mm-hmm. They're going to generally, let's just say that most people stick to the center of their lane. When I drive it, I have two vehicles. One is the Tesla, and the other is a very large 24-foot Sprinter van. When I drive that Sprinter van, I do not want to have to make hard turns. So if I can see that nobody's there, I drive in the other lane and cut across lanes just to soften the radius of the turn. When I'm driving the Tesla very fast, I mean, let's leave out what very fast means, but I do the same thing. Speed can come into play here. Are they obeying the speed limit? Do we just want to throw out the data where they're not obeying the speed limit? Because they know the speed limit, that's for certain. That's a pretty easy data set, and they display it when you use the map. They'll display the speed limit. How would they select on throwing out things that don't make sense or people who are driving recklessly?
I mean, again, I don't know for sure.
Not that I drive recklessly.
Yeah.
I mean, of course, I take precautions.
Right. I can't say for certain, obviously not being in those organizations, but I have a pretty good guess knowing what typical enterprises do today. And that's that you want to save all of that data, but have a mechanism for like tagging it or making it easily sortable, filterable, so that if I, depending on what my needs are to train something or to work on any aspect where I want to use historical data, if I want to sample from the total population of anything, I can do that. Or if I want to sample from people who were obeying the law or people who specifically got in accidents, that I should have some mechanism to query that data set and get example, driving segments of what I need. So in terms of would they throw anything out? No, you save everything, but provide your engineers and researchers the mechanism to query it efficiently.
So yeah, that begs a question. There's a lot of data.
Storage is cheap.
Yeah, storage is cheap. If they're probably saving high frequency data points about where you were and the vector you were on. A 10-mile trip is fairly puny amounts of data, right, in the grand scheme. Mm-hmm. Do you think they're processing it on the vehicle or they're processing it in the cloud? Are they sending the data, the raw data, or are they processing it on the vehicle and comparing it against some existing machine learning or neural net? Because they've talked about how amazing the processing is on the vehicle. Are they doing, pre-processing there and sending something that's modeled into the cloud?
Same answer preambles before. I can't know for sure. I would guess they're dabbling in a mix of both, but probably doing the former, that they're just sending all the telemetry data whenever they can get a chance. There's things that they probably don't send, privacy stuff. They scrub or aggregate to certain levels just because you don't want raw data going over whatever network it has. But you don't want to do too much on that vehicle for two reasons. One, because you don't want it that autonomous. You don't want that thing to learn independently. That does not sound like a good idea, even though technically you could do that. And secondly, because the opportunities for stuff like this, like a system called Federated learning, where you have a network of edge devices that are participating in a distributed machine learning task, that's a very up-and-coming idea. And your R&D risks are a lot higher on it versus like plain old machine learning where you can't really mess it up because the path is so well cleared. You just follow standard best practices. So most likely it's shipped back, whatever some efficient packet of data is, everything's trained server side, and then you deploy your updates in batches, and you manage those in a very release-driven fashion. That vehicle should really be a dumb terminal executing on a well-proven model.
Yeah, so you do get software updates. I would call it quite often. We've had, I think, 2 in the last 2 weeks. And you're connected to Wi-Fi typically to do the software update. You just connect it to your home Wi-Fi. I'm not sure if you can do it over cellular, but in that time period, there's probably quite a bit of data exchange potentially.
Yeah.
Going up and down, meaning to the car and from the car. helping update the models in the cloud. So what was the other, the more riskier method you spoke of just a moment ago? You said there's two, traditional ML, and then there's a new up and coming. What was that?
Federated learning?
Yeah.
A lot of it stems from privacy concerns. So people are scared. They want to opt out of stuff, right? They don't know what their data is doing. And that's respectable. Although when you opt out of everything, it also means that system can't learn to be better and understand your needs and your behaviors. If you leave or are willing to give all, check the box that says there's analytics data that'll be submitted anonymously, that allows the software manager to watch you struggle, observe a problem you're having, and then fix it. So those are things you kind of want to opt into. But do you want your private search data, for example, of what you're searching for on the web, all going back to Google? Maybe you don't, or something like that. Maybe there's an in-between here, and that's what federated learning seeks to be, where instead of necessarily sending back your private data to be part of a training set on the cloud somewhere, you're doing like a little incremental version of an update, and you just transmit back what the changes are. So if machine learning is about guessing the proper values for 100 parameters, you just say, here's the changes I want to make to the 100 parameters, and they average that in a smart way across all the participants in the learning, and that you get this sort of anonymized collective learning process.
So with the vehicles, we've talked about data being local to the car, uploaded. If I was to project forward and try to, not forward, but if I was to try to figure out how they're doing it, I could drive a road horribly many, many times and see if it influences the behavior of the vehicle when I put it in auto steer. Like drive down the center of the road all the time as best I can, unless there's a car there. And in theory, I would be training it. But, obviously my guess is it wouldn't work. But that would be one way, like see if you can see an influence in it.
That is an interesting adversarial attack.
I'm not saying it would, but the point is it would isolate whether or not it's mimicking your driving style or the safe driving style, right? And there's no way that it allows you to influence it so greatly that it makes it unsafe. But it is an interesting thought experiment for listeners to kind of, I'm more illustrating how engineers think, like where's the edges of what we can do, and that would bring about some change that we can see. And once we know what the edges are, then we kind of get an idea of how it might be operating. And again, I don't think it would work though, because I think it's going against that larger model. And I do think the larger model in the cloud exists. I think a much larger model of the safe driving method for any particular road exists. That model is then synced with the vehicle, and that informs the sensors. Obviously, it doesn't go blindly, but it informs the sensors to know where to be on the road, and the sensors then account for obstacles and react real time. In case there's a person, a vehicle that they need to apply the brakes for, et cetera, or stop signs, et cetera.
Yeah.
But that would be my guess. Is layer one is just what's the safe driving path. So you're doing path finding, right? I'm not sure what the term for that is, but they're using machine learning to find the safest path. And then they're augmenting with the sensors on board in real time to make sure they don't hit anything. I mean, and that's a simple way of describing it, but that's my guess. So, do you agree?
Yeah, fairly good summary, yeah.
So when we take Lidar or other sensors, if I'm to think about it, and this is with no experience here, but some type of radar sensor, which radar can bounce around things and give you a picture of what's ahead, would be useful, because if you see that an accident is coming ahead or people are slowing down ahead, you can predict and know that the person in front of you, maybe they haven't yet hit their brakes, but they are going to. So useful, yes. Lidar, I don't quite fully grasp why LiDAR. I think the only reason LiDAR a nice to have. It is because it can sense the environment in a much more accurate way because it's scanning for depth. I think LiDAR can tell you temperature as well at different distances. But it certainly has a better picture of depth. It's a better sensory system than pixels on a camera.
Yes.
But I don't think it can see around because LiDAR is laser. It's a form of light, right? If I remember correctly. Again, back to our initial premise that I think it's entirely possible. Those are bonuses. Those two other sensors seem to me to be a bonus and something that is nice to have, but based on, LiDAR is way more accurate than the human visual system, if I'm not mistaken. I don't think first off, the human eye refreshes at brain refreshes at roughly 60 frames a second, right? And the vehicle is that much faster and can react much, much faster than the human limbic system. What do the additional sensors buy you? They buy you more fidelity in what you're seeing, but at what cost? And I think that's where Tesla is driving towards. They want to make a system that is reasonable in terms of cost because LiDAR sensors are expensive and probably not only are they expensive, but they might be more not error prone, but they might have more failure rates because it's a complicated sensor.
I wouldn't worry about that exactly. Machine learning is really good at filtering that out.
Well, failure rates in the sense of a replacement part, right? It's just a failed part and they need to replace it. Because cameras have been around a lot longer. They're probably more robust, simpler technology. So there's probably reliability there. I could argue it the other way with redundancy and say the redundancy is better. With LiDAR?
That if one system goes out, the other system will still be up.
Oh, in terms of cameras and then having LiDAR as a layer above the camera?
To me, the argument really isn't the engineering at all. Because at the end of the day, if you beat the game, if you make the actual autonomous vehicle that can just drive, it doesn't matter. We're going to drive the price to zero over time. So put whatever you need on it to win the game right now. So LiDAR shouldn't be required because the vision, if we can do it with vision, so can the machine. The question is, does it give such a strategic advantage that it can somehow make up for the limited current state of the cognitive abilities of the trained model? If that advantage gives it some way to sneak across the finish line faster, then it's worth doing.
Right, and I think that's the main question: is what are we getting out of the adoption of LiDAR that you can't get with the visual system? And I think it's just fidelity.
Correct.
Right? I think
that's
it's just
100% correct.
That's it.
That's the only thing. Yeah.
And we already know that, and I believe that cameras have as good a fidelity, if not better, than the human eye.
Yes, correct.
They already have better fidelity with just a camera than the human eye. LiDAR adds yet more fidelity. If you could have both, great. But then there's the cost trade-off, because I know that Elon Musk is very good at considering how to create a product that meets the business model. That's something he's tremendously good at. So there's probably not enough fidelity that adds enough value to where it justifies the extra cost. And that's pretty much what it comes down to. And the same thing probably goes for radar sensors that can see around things. If the Tesla is not riding someone's bumper when it's self-driving, you've got nothing to worry about, right? You can stop as quick as the car in front of you, and you know it, and you can react faster than that car in front of you. So seeing around things doesn't really buy you much other than having an extra sensor that doesn't afford you much. It doesn't afford you, any more than just having the visual sensor. Unless,
and I don't believe the argument, but just to steelman it, unless you would say that the current bleeding edge of what machine learning is capable of learning is limited to the degree that you have to make it super sensory in order for it to meet the basic level we need.
Well, maybe let's paint a scenario here. I don't trust that the person in front of me sees the human crossing the road.
Sure.
Right? So there's a case for radar, right? Maybe we're seeing around things because we don't trust the driver who's actually driving their vehicle, we don't trust that they're not looking at their phone and they're about to kill someone.
Right.
So we want to make sure that we take evasive maneuvers there and don't just pay attention to the car in front of you. But the problem there is that, and again, this is off the top of my head, that it still doesn't change that that person is about to kill someone. All it does is tell you slow down sooner. But you were going to figure that out the second the person in front of you eventually hit their brakes. You just wouldn't run the person over the second time in case they flew over the hood.
Well, I mean, more likely what the current state-of-the-art vehicle would do is probably come to a full stop as quickly as possible, I would guess, because it would recognize the disturbance. I don't think it's going to rear-end the car in front.
No, it won't. That's my point.
Yeah.
It won't. So you're not buying a lot by the person is. So the responsibility lies on the person in front of you, right?
Yeah.
To not hit the human. Seeing around that vehicle with radar would allow you to see that that person's about to get hit. But it doesn't change that they're going to get hit. It just allows you to preemptively slow down sooner in case, the person flies over the vehicle when they get hit and you don't hit that person. Do you see what I mean?
Essentially, I agree with you. But if I were to take the other side and say, let's put down machine learning and say it's not good enough, it would be, and this is true, that in this scenario where you've recognized, there's a kid up ahead and there's an obstacle, maybe there's two guys walking with a giant heavy piece of glass and there's clowns around, just weird stuff, you enter this heightened state of awareness, right? You're like, this is an unusual circumstance, and your mind starts planning. You start thinking of scenarios like, well, what happens if this? Do I go into that pit and all that? Now, that's a very human experience that you need to achieve that state of awareness, maybe get some adrenaline going. Machines should not need to do that. But what a machine doesn't really do today that ML's not good at is deciding now is a moment for me to do some specific planning and expend a lot more energy and compute than I normally do thinking through my next 3 or 4 chess moves because I'm entering a weird moment here. That is something that maybe the Lidar would help with, but honestly, that's algorithmic concerns. I don't know that the sensors matter that much there either.
Right, but I also think there's something interesting about the self-driving vehicles that first come out having to account for, in some fashion, the behavior of humans that are driving on the road. Are we going to preempt and take, like you said, take evasive maneuver, not evasive, but cautionary? Are we going to be in a heightened sense of awareness if we knew that person's about to get hit?
Defensive.
That's an interesting question, but again, it doesn't change outcomes. That person's going to get hit because you're not in control of the car in front of you. Unless cars start talking to each other, and that's a different story.
Well, sure. That's the easier of the two problems.
What if you have 5 people in the car? Does it know you have 5 people in the car? And you get to choose to go over a cliff or kill 2 people that are on outside.
It could pick contrary to your ethical instinct, is what you mean to say.
Right. These are tough questions. I'm curious I shouldn't say how. I'm curious to see if these regulatory type questions or these questions that are going to be thought of and answered outside of Tesla, within the court system, within the moral landscape, so to speak, of society, when those questions get answered, is that going to change the sensors and the methods they use to achieve full self-driving?
No, we're going to have to figure out how we legislate this because you've oversimplified it. There's no line of code you can point to that says if victims 1 is greater than victims 2, then go with scenario 1. It's not as black and white as that. You can only say, you can legislate what the intention should be under circumstances, and we can propose a series of tests for how the machines demonstrate that under all known or presumed behaviors, they exhibit the behavior you want. But in the real world, there's too many infinite sets of possibilities. There can't be a must or has to or whatever.
There's going to be mistakes made, and that's going to inform what happens next. But those mistakes would have likely been made without, machines being in the way anyway. The mistakes of humans are going to be far greater in all the broader landscape, like you mentioned at the start of this. They're better at avoiding accidents right now. So in all likelihood, the statistics will look better for the machine in the broad sense. Will there be these outlier events that cause tragedy? Yes, but those happen anyway with humans. But I do think that this is we've gone from the near term and what is to, the future questions that will be asked, and I think that's fascinating. So